A warm welcome to everyone. I am KRISHNAN of 30th Triple Department of Teachers Engineering College and VIMAL followed by me. We are going to present a topic about carbon dioxide laser in the fiber optics and laser and instrumentation. Let's get started. In the introduction, the CO2 laser is a typical molecular laser, which means a typical means a distinct quality. It is a type of gas laser and it emits a laser light of wavelength of 10.6 mm. Its beam power ranges from several watts to 25 kilowatts or even 100 kilowatts. Working of CO2 laser. The active medium of CO2 laser is a mixture of carbon dioxide, helium, and nitrogen gases. The approximate ratio is about CO2 is to N2 is to He is equal to 0.8 is to 1 is to 7. This is the ratio where the CO2 laser is being working. Pumping is realized by AC or DC electrical discharges. First, most of the electrical discharge energy is absorbed by nitrogen gas. Only a small part of the energy is absorbed by CO2 gas. So, the ground state is the rise which rise the from the ground state to the upper state. The larger amount of CO2 molecules collides with the nitrogen molecules and gain the excitation energy. Once the excitation is achieved, the CO2 molecule at 001 state will give out energy and jump to the lower energy state 100 or 020, thus giving out laser light at frequency of 10.6 mm or 9.6 mm respectively. The remaining decay from state of 100 to 101 and 020 or 010 or 010 to the ground state 000, which dissipate energy in the form of heat instead of light. This is the energy level diagram where the electrons move from the ground state to the excited state and returns from the excited state to the ground state at a frequency at a wavelength of 10.6 mu meter. Thermal diffusivity. Helium has a high thermal diffusivity, while the thermal diffusivity of CO2 is low, hence helium is used. This combination makes the CO2 gas to have high lasing efficiency compared with other lasing materials, and at the same time, the system also has a good thermal diffusivity. Thus, the role of helium is evident. Okay, the following slides will be continued by Vimal.
The following topic is continued by me. This is the cooling design which is given to the CO2 lasers because while the laser is emitted, a high amount of heat energy is produced. For cooling this, the CO2 laser is cooled. There are three basic cooling design are used. One is slow flow laser and fast axial flow laser and transverse flow laser. Slow flow laser, it is a too high temperature. At too high temperature, the low energy level of the CO2 molecule inside the laser cannot be equipped to the ground level fast because due to the population inversion, the drain uh, the molecule from higher range must come to ground range to emit some laser. But while the two temperature is acute, it can't able to reach the ground stage. So we needed to slow for we needed to cool for slow flow laser cooling is to the wall capacity. It is typically about 201 meter per minute, or coolant flow is about 71 per minute at a room temperature. Axle Fast axial flow laser. The laser used very conventional for cooling the gas flow at the speed of 300 to 500 per meter per second to the discharge zone. The flow discharge and optical oscillation are also along the optical axis, which favor the symmetrical power distribution of the laser beam. The typically power gain is about 10 times more than the slow fast laser. Comparing to that, it is very high. The output is declared by the cooling efficiency only. Then the transfer flow laser. The axial converter cooling is good for a symmetrical beam energy distribution, but the transfer flow design is more effective than a compact high power laser or design anyway. Only one disadvantage is the lack of symmetricity. Then we see about the application. This laser were widely used in many applications. It is used in a laser machine for all cutting property in industries and for a welding instrument, and it is also used in a medical department for a treating a skin treatment for cancer patient and so on. Thank you.